All right, welcome guys. In this video, we are going to be starting off our introduction to exponential functions. All right, so let's just jump right into this. All right, so we know all about linear functions. This is our y equals mx plus b, and we know that these functions increase and decrease at a constant rate. All right, so just think about slope, right? As you go over 1, you're going to go up or down by whatever that slope is. So in this little chart I did over to the right side, we can see that every time we go up 1, every time we go right 1, every time our x increases by 1, our y value increases by 2. Again, every time that our x value goes up 1, we're just adding 2. All right, and that's our linear functions. Slope is 2. Nice and easy here. As we move on to exponential functions, we are no longer going to be adding as our y value increases. Instead, this rate of change is now going to be multiplication. So on the left side, we can still see, all right, my x value is increasing by 1, increasing by 1, increasing by 1. But now what's happening to my y values? Well, my y value is now being multiplied by 2, multiplied by 2, multiplied by 2. All right, so instead we are now multiplying as our y value increases. So we can see that these functions are going to increase rapidly. All right, all of a sudden it jumps from 2 to 4, 8, 16. By the time we hit x equals 4, we're at 32. So these really can increase very, very quickly. All right, so exponential functions, we're just going to quickly talk about exponential growth versus exponential decay. And we see these all the time in real life, and we'll take a look at some real life examples in a second. Our exponential growth is just going to be when something is increasing at an exponential rate. When it's getting multiplied, 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 it increases very quickly. Versus exponential decay, which is where something is decreasing at an exponential rate. All right, exponential growth, this right here is just kind of the graph of what exponential growth looks like. And we can see that it looks like, all right, at first it starts off kind of flat, and then suddenly it just starts to take off and increase very quickly. Whereas exponential decay is a little bit different. It starts off by decreasing very, very fast, and then it starts to flatten out towards the end. And we will talk about why that is and talk more about the actual formula of these exponential functions soon. All right, and lastly, we're just going to examine some examples in real life. So maybe we're talking about the population growth, all right? It's not exactly exponential, but we can model the start of population growth exponentially. Maybe it's the interest that you're accruing in your bank account or the interest on a loan that you had to take out. Or maybe you're saving up for retirement and it's interest. We're definitely going to do some cool stuff with money in this chapter. Also relating to this coronavirus pandemic, right? The spread of a virus can also increase exponentially. And then as far as decay goes, maybe we're talking about the decomposition of some bacteria or some material, or maybe even the decomposition of caffeine in the body. When you drink your coffee at 2 p.m., how is that affecting your sleep? Because how much caffeine is left in your body by the time you're going to bed at night? So exponential growth and exponential decay, we're definitely going to do some cool real-world modeling with that in this chapter.